Good morning, Codegarden 2021, and what a pleasure it is to be back. I've unfortunately the past few years always been lumped with this first morning slot, so I hope there's some people here ready to talk all things search in Umbraco. But I've been really enjoying this virtual conference so far. It's kind of become a regular thing for me now, speaking at virtual conferences. I cannot wait to be back in person. Anyway, as I said, my name's Callum, and we're going to be talking about making search friendly in Umbraco 8. I'm a Microsoft MVP, an Umbraco MVP, and the technical director at Bump Digital. We've got an awesome award-winning team that have been doing the rounds during Codegarden, as I'm sure you have seen. So why am I talking about this today? Well, I've probably on the past year or two been on a bit of a mission to make search friendly in the projects that we work with, but also for the community, because I think historically search has been something that has always frustrated people. It's hard, it's difficult, it's complicated. When you run into issues, it's actually kind of stressful. I'm sure everyone at some point in their Umbraco career has hit an issue with building a complex, potentially, search experience and has had to hit up someone on the forums, or has perhaps been diving through blogs and really complex technical articles on, say, Stack Overflow, for example, trying to explain exactly how all of this works. And I don't think it has to be like that. I think we can make search easy to understand and easier to implement in your projects. The chances are you've probably heard of one of these 4 packages. These are some pretty common, popular ways of performing search in Umbraco. Now, there's probably a bit of a blast from the past here with a few of these. XSLT search was probably one of the original search solutions for Umbraco, and it predates even Examine being available for Umbraco. This was built by Doug Robar in like 2009 or something. There's also Easy Search that Matt built in 2011, I think, and then full text search, and also full text search in version 8, which Soren Koppel's taken over. These are some incredibly powerful solutions, easy ways of getting up and running with search in your Umbraco solution without having to worry about it. However, they don't quite do everything you'd want them to do. So if you have a requirement for more complex searching, more complex filtering, these aren't really going to do it for you. These are plug and play. It works out of the box, but it does what it says on the tin. So how do you, when you want to go a bit deeper, how do you do that? Unfortunately, there's not really that many great resources. I know Paul Seal in recent years has done a really good video series on search, and there's some great articles. Whenever you search in Google for like help with an examine question, you always get probably one of these 3 articles coming up. So Examining Examine that Peter Gregory wrote back in 2011 is on the Umbraco blog. There's also Ismail Mayat's Seek and Ye Shall Find talk from the UK Festival in 2012, which again, a treasure trove of really great information about search. And also Rasmus Fjord's articles in 24 Days. I think he had another one in 2015 as well. But 2013, 2015, he's got 2 articles about using Examine. These are kind of the only really advanced bits of information about exactly what search does and how it works in Umbraco. So today, I'd kind of like to try and demystify some of the things that go on internally for you. I want to talk about the why, not the how. I'm not going to really tell you how to implement search. I actually want to talk to you about how it works internally. And there's a very good reason for it. I think this is a really useful, broadly applicable skill. It's something that actually doesn't apply just within the Umbraco sphere. It's something you could use in your day-to-day job, maybe with other tech stacks. We'll just go over some terminology quickly to make sure that everyone is on the same page with this. So Examine, you'll be hearing that a lot, and if you've been around Umbraco a while, you're probably aware of what this is. Examine is a .NET API, a wrapper, around something called Lucene.net. Lucene.net is a full-text search engine, and this is ultimately what powers all of the search that you do in Umbraco, whether you're using any of the off-the-shelf packages or writing it yourself. Today, we're going to really dive into some of the core concepts of Lucene.net and see exactly how it works internally and how that maybe then affects the code that you write. An index, of course, is where we store all of our data. So Lucene.net and Examine will work together to gather all of the content in your Umbraco install and drop them into an index, and that's a kind of a data store that can be queried and filtered upon. And then we've got the kind of more technical concepts here, which is analyzers, tokenizers, and filters. And they are ultimately responsible for turning your query and your data into something that can be searched and something that actually returns results. The key theme here is tokens. Tokens, you're going to hear this coming up a lot. Tokens are the values that we're going to be storing in the index and that we're actually going to be using to query the index. So an analyzer, it produces tokens, or actually a token stream, for a given query or a stored value. So you give it a string and it will pull out of it some tokens. It also does some other work in the background, maybe to strip out common stop words, things you don't want going into your search, just for safety, really. A tokenizer then breaks your queryable token values actually into individual queryable tokens, and a filter is then what actually applies those filters to the index. So you give it a token and it tries to match that against documents to rule things in or out of the index. So this is a term that you will also you may also come across. It's an inverted index. So when we think of an index, we kind of think of a database of some sort. We've got an ID column and then some columns for all the values. Well, that's not actually the case inside Lucene.net. So Lucene.net creates something called an inverted index. And a common analogy here is comparing this to the index at the back of a book, where you've got a list of terms and the corresponding page numbers where you can go and look those up. So rather than having ID and here's all of the values for that are present on that document ID, instead it reverses it. So it will create a list of the individual tokens, the terms, and the IDs in the index of where you can go and find that information. This means that it's really efficient to actually query. So when we do a query, we check the tokens. We go find me any documents where this token matches, and we can get back a list of documents, do some sorting, do some filtering, do what we need to do. So another concept that we need to get our heads around is this idea of Boolean search. Lucene uses something called Boolean search, which is a kind of additive and or not type search. Imagine in a library where you're going and you're saying, I'd like to find this, a book that has this, and it has this, and it has this. A requirement I often hear coming up from clients is we want our search to work like Google. And whilst that's fantastic in principle, in practice, it's not so simple. Google does something far more advanced with natural language processing. So it's effectively a natural language search engine. An example of the different types of query that you might execute here would be find me articles with giraffes and unicorns or rabbits. That would be an example of a Boolean search where you're building up effectively a set of operations, set of commands. Whereas a natural language search might be more something like, I want an article with a giraffe and a unicorn, or maybe a rabbit instead. And the natural language processing is able to determine the nouns that you're searching for in there, a giraffe, a unicorn, and the rabbit, and then itself apply operations based on the context that you've wrapped those in with, like a sentence, for example. This may not be the type of query you would type into Google every single day, but if you were to ask Google Assistant something, this is the kind of query that would ultimately end up getting executed. They're not the same thing. If you're going to try and build Google with Lucene.net, you're probably going to be in a bit of trouble. But ultimately, Boolean search is something that's used across most Lucene-based search engines. So that includes Examine that we use in Umbraco, but also includes Elasticsearch or Solr, which are incredibly popular, more enterprisey search solutions. So the concepts that you learn with Umbraco and with Examine actually can be applied really broadly too. You could go and use those same principles for Elasticsearch. The key here, though, is of course you need to find out and kind of identify the different terminology. So whilst in Examine, there's been a load of work done to make the API a bit friendly and kind of familiar to Umbraco developers, even though it's not an Umbraco thing. It's masking some of the deeper complexity in something like Lucene.net. So let's talk about Boolean queries. You'll probably be familiar with this stuff that we're seeing on the right-hand side here, query and field query or query not. These are things in the Examine API that let us actually perform queries. But what does this do under the hood? Well, these are actually performing a must, should, or must not query. When you start to think about the actual goal of what you're trying to search for, these start to make a lot more sense. So if we jump back to this example here, I want articles with giraffes and unicorns or rabbits. In this case, we're going to say my query, the documents that I match must have giraffes and must have unicorns matched in them, but they should have rabbits, should being kind of optional in that case. So this is what we're doing when we're building up a query. And the underlying syntax that actually creates, like I said, is called a Boolean operation. So that's these things here. You can see that an and or a must query will put a plus in front of it. It says this is required. This is like additive. I need to have this and this and this and this. The should has nothing. It's a default. Just give me this field with this value. And must not puts a minus in front of it, like to negate that, to say I do not want this. And by the way, you can do these kinds of searches in Google too. So if you really want to say I specifically want this or it must have this, you can put a plus or a minus in front of things to actually start to filter things out more. So this is a concept that applies really broadly across the board. Now you'll see as well that we've got brackets wrapped around these terms, and that's something called groups. This is also facilitated in the Examine API. So you can go query grouped and grouped or grouped not. And what this lets you do is build up chunks, groups of terms and queries that you then need, and operations that you then need to execute. So some examples of that would be a grouped and would be something like plus field value plus field other value. So you can say, find me the document where both of these values are present in this field. That would be and. The grouped or obviously doesn't have those minuses in front of it because it's just saying find me this or this. And the grouped not would say I don't want that and I don't want that, so it puts the minuses in front. Now we can start to build up some really complex queries here because query.and will prefix your group with a plus, a minus. So basically prepend the operation to before the group. So in this case, let's say I wanted to say, find me all the fields where these values are present, or all the fields where all the documents where these values are present. So in this case, I would have two grouped and queries, but I'd go query dot and grouped and grouped and. So you can kind of start chaining them, and you'll then get another plus added before this query group. So you can kind of see how the kind of logic starts to be built up there with these pluses and these minuses. And I think once you've started to understand that, this really makes a lot more sense. People often get confused about should I be using an and or an or not. But I think when you think about this as an additive operation, it just makes a load more sense. So let's look at some common search scenarios that we see in Umbraco, because these are things I actually see people doing wrong a hell of a lot. And I'm going to explain how we can maybe make this a bit better. So we discussed earlier that we have this idea of analyzers. Analyzers take the data that comes into the index and they modify it, they tokenize the values to make sure that we can search upon those. And in doing so, they do things like stripping punctuation out. They do things like ensuring that you've not got any stop words in there, like not or and, things that might actually affect the query. So this is an example of some data that we would have indexed. In the index, every field has both a value and has tokens. The tokens are what actually ends up getting searched upon. So the value that gets written to the index isn't necessarily what you're going to be searching upon. Let's look here, two different options. So querying by path, I think this is pretty common, where people may want to say, restrict this bit of content, restrict the search to just this one bit of content, all nodes underneath this bit of content. And equally, querying by a friendly name is quite a nice thing to do. When you have, say, a search where you want to filter by category, instead of passing the node ID through as a query string, you want articles, the name of the category, to appear in your query string, and you've got to feed that through somehow. So these two examples where I want to search by path, or I want to search on the path field where it's got the value 2922, or the categories field where it's got the value articles. Now you can see by default, yeah, 2922 does appear in the tokens for path, so I should be able to search on that. For categories, there is no articles thing there. It's just a UDI, actually, an identifier that's coming out of Umbraco. So you'd assume, okay, this path thing's going to be fine. It's all going to work nicely. Actually, that's not the case. You'll notice if you look at some of the other tokens in this example, it has split wherever you had punctuation, it split those into multiple terms. So actually categories is split as space document space and then the GUID of that document. In the case of the name, search is hard, is a stop word, and so it's actually stripped that out, and so we only get search hard in the index. And in the case of the path, because this is a complete string with no spaces, no stops, no nothing, it's actually treating this as a value in itself. So if you were to try and match the path to 2922, it's not going to match. The value isn't 2922, it's 1, 2922, 6756. So this is not going to work out of the box. There's also this date thing, which we'll talk about in a second. So the common way that this is fixed is through injecting values. Now, every tutorial you'll watch tells you actually this is the way to do it. So if you want to be able to search by path, you need to make sure that your values are split out in your index so that you can search upon them. And if you want to do something like searching by a friendly alias, such as articles here, you need to inject that also. So the recommendation is you go and create a new field in your index through an event called searchable path, and you split out the strings to make sure that they're formatted correctly. Oh, there should be a code sample there. I don't know where it's gone. Sorry. Okay. It was here. Weird. So this would be the code sample where for path, you would, in your indexing code, say, hey, where the path field exists, I just want to replace all of the commas with a space and try and add that to the index under a field with the alias searchable_path. And in the case of categories, we get the value, we go and look up the content by that value, and then we can construct some kind of meaningful string that allows us to search upon that. In this case, it's got the content ID and then the URL segment, which is a friendly alias we can use to refer to content, and we then inject that into a field too. So we've got these fields, and it means now when we look at these queries, instead of going path : 2922, we would instead go searchable_path 2922, or whatever you've called your field. This works. That's brilliant. However, there's a downside of this. You've effectively duplicated data in your index. You've got both a path field where you have identical data just with commas, and searchable path field where you've got identical data just without commas. This is a bit wasteful. And actually, if you do this across a load of fields, it's going to start really adding up quite quickly. So how should we be doing this? Well, let's talk about tokens again, because tokens are really, really important. As I said, each field in the index has both values and tokens for those values. And those tokens are what are used for actually performing the search itself. What we can do is create a custom tokenizer that will say, hey, I'm going to process those values appropriately so that they get injected into the index in a way that I can actually search them. Umbraco won't do this out the box, but we can configure it to do so. So in this case, I've got an example of a path tokenizer. So for my path field, I'm going to say, hey, I want you to use this analyzer and tokenizer whenever you go and index data for path, and I want you to split it. So wherever you find a comma, it may be too small for you to see, but wherever you find a comma, I would then like you to use that as the separator between the individual tokens. And what it will then do is it will take the string, read through the values. When it finds the comma, it'll go, stop. This is now the start of a new token, and the next part of your path will be indexed properly. This effectively achieves the same thing as we had before, but it's going to index it into the single field. The same could be done with a picker. So in this case, I've actually used a custom field type, which you can register as well, a picker field type in this case. And what it will do is there's a method on it called add single value. You can take in the value, you can go and look up and munge whatever data you need in order to get this to work, and then you can manually write those values to the index and say these are the values that this field should be storing. The benefit of doing this is you can control how it should be stored or not, or if it should be analyzed or not as well. You'll see here I've got two operations. So firstly, I'm taking the value which is a UDI. I'm parsing it just to make sure it's definitely a UDI. And then below, I'm writing that to the index. And I'm saying, yep, I'd like to store that. So by saying store that, it means it's stored in the values of my field. But I'm saying I don't want to analyze it. And the reason I don't want to analyze it is you saw before how it stripped my UDI from being /document/ to being and then document and then the GUID. That I want the value to actually stay intact. So we say, no, I don't want to analyze that field, that value here. But we can add additional values into the same field. So in this case, I'm going to also add the URL segment for my content. This is this friendly alias we want to be able to search by. So I'm saying, though, I do not want to store that in the values, because there's no point in having that actually in the index values. I'm only using it for searching. So again, we say, no, actually, I don't want to store that here, and we don't want to analyze it in this case either. So what's the output? Well, we no longer need these searchable path or searchable category fields. Instead, we have a path that the value, which is what you're actually seeing on the left-hand side here, the value is exactly as it was and exactly as it was written before, but the token, the value that gets saved and generated and that we search upon is actually the value that we want, and it's formatted in the correct way. We no longer need these duplicated fields, and we've got a bit more of an efficient index, which is nice. We'll quickly touch on paging and sorting as well. This is something I see done wrong so many times, and if people attended Shannon's amazing talk yesterday, you'll be aware of some of these things. So firstly, query.execute returns an IEnumerable of results. If now you do toList, you've got a list of those results, it's going to enumerate all of those. If you then do skip and a take on that and you page through it, you're actually paging the full collection in memory, which is not very efficient at all. And it's going to mean you're going to have to fetch, hundreds of results up front in order for your paging to actually work. So you don't want to be doing that. The other thing that I see people doing a lot is saying query.execute, that's great, and then doing order by to order the results, in this case by name, just a silly example, and then doing a skip and a take. Well, again, you may not be aware, but this .order by is also an operation on the IEnumerable. So you are going to enumerate the results in memory, and you're going to order them in memory and then page them. Really, really inefficient. Do not do that. So the correct way to do this is to use sortable fields actually on the results themselves. So you can do order by sortable field and run that. You can then skip and take, and you may even want to go and get the published content for those items so you can render them in the first place. Don't do this either. Again, this order by operation, if it's coming after execute, it's happening too late. Examine isn't doing the filtering or the ordering. Instead, you are doing it in memory, so don't do that. This is kind of the recommended way to do it. So you do your query, you do your order before you actually execute the query, then you'd execute it. You can then skip over it, and we'll talk about why that's important. Here, I'm then going to go and get the published search results first. Then I'm going to take the amount that I want, and then I'm going to toList it. The reason we do the skip, then get the published search results, and then the take is because this is an IEnumerable. So it will iterate until it has found, or take will keep iterating until it has found the full 25 items that we've actually specified here. So in this case, if you maybe had some nulls or something that wasn't quite right, this would mean you'd actually definitely get your 25 items. So let's talk a little bit about this skip function. So skip and take, people may be aware of from link. This is something you can do on an IEnumerable in C#. You can skip through a number of items and then only take a certain amount off the top of that IEnumerable, and it will enumerate and get the values that it needs to. Examine doesn't do this. So examine actually has overridden the skip method on search results. So when you go examine search results.skip, it's actually going to perform a paging and a querying search under the hood. So in this case, it will check to see if you've tried to sort by a field, and it will then, based on that, determine which internal Lucene method it uses to go and find the documents for your search. So skip is actually performing the search. You may not realize that. When you go search.execute, the search hasn't been actually executed until you've started paging those results. The tokens that we discussed before are already sorted and scored when they go into the index based on their prevalence. So if a token appears a lot, it will be given a higher score, and if it appears less, it will be boosted down the results. So the top score doc collector, which is responsible for when you're not doing a filter, for scoring and rendering the results, it will execute the query, and based on the terms in that query, it will boost up or down documents based on that, and it will give you the items back. The top field collector is when you're searching and filtering by, and sorting by a field, and it uses the field comparator to sort the results by a specific field, and it completely ignores the document score. So you may have seen examples where people do boosting and boosting up and down on indexing time. If you're going to do then order by field, it's completely redundant. Don't bother. This is effectively just comparing the values, the tokens in the index against your query and saying, yeah, that's greater or not. Now, this all seems really crazy, so I'm going to give myself a shameless plug here, which is a package I've created. It seems really, really crazy that we write the same bits of code, these things. We write these same things to parse the path or filter our categories. We write that in every single project we do. And so I've actually bundled this into a package for you and tried to make this as friendly and as easy as possible for you to configure. It's called Search Extensions. There's a QR code down there. You can go and check it out on GitHub. But ultimately, what it lets you do is it will properly index dates, paths, content pickers, UDIs, even JSON objects, and you can really customize this. It can get quite advanced, but out of the box, it gives you a friendly API where you can do all of this. It also lets you do some common operations you may want to do on content searches, like checking if the item is published, or if it's visible, or if it has a template, even searching field values based on their culture, which is not something that Umbraco and Examine lets you do out of the box. There's also, because paging is just done wrong so often, so many times, we've got a really handy results.page extension where you can actually go and say, give me the results strongly typed as published content, and it will go away and fetch those for you in the most efficient manner. I was going to do a demo, but I'm running out of time, so I will not. We can touch on it incredibly quickly. Now, the final thing I wanted to talk about is faceted search. I think this is the holy grail of search, actually. This is where you want to show a list of all the possible options to a user so that they can navigate and browse to the results that they actually want. In this case, we're saying, I'm doing a search for breakfast, and we've got, let's say, 3 categories: eat, drink, and cook. And it's coming back and telling me this is how many results exist in each of those categories. So there's 32, 47, 10 in the various categories. Now I want to be able to drill down into those results and say, hey, tell me the subcategories that are available and only show me the ones that are available. So you'd have something a bit like this. I've selected drink, there's 47 items, and it knows that coffee, tea, and accessories are all the subcategories available for that. How would you build this? Well, most commonly, I've seen someone do something like this in Umbraco, which is fine. Maybe it works. Umbraco.children, go and get the category nodes, and then do a little bit of in-memory filtering. If you've got a few, that's probably fine. If you've got a more advanced, more complex category structure, this isn't performant, and quite frankly, it's not accurate. So maybe you have a kind of a matrix of categories where something could exist in multiple. This is just not going to work. So how do we do this? Well, in Lucene, there is something, in Lucene we can do something called faceting, and that is where it will identify which terms are available in which fields, and we can say, I want to go and get a distinct list for my query where all of these categories actually match a document. And just a little bit of maths for you. So this is actually what's going on under the hood, where it's effectively finding the common values between the full matrix of the results of your search. This is ridiculously complex, and you're not going to want to implement this. There's libraries that do this very nicely, such as Bobo Browse, such as multi-Lucene facets, such as simple facets in Lucene 4.8, which is coming with Umbraco 9 as well. So there's loads of options, but actually the configuration isn't friendly. It's not very, you still kind of have to understand exactly the query that's being executed. So I decided to take this into my own hands. Now, very quickly, I'll show you an example I've got up and running of facets running on the blended store. So this is the example vendor store here. And it's got a few products, and it's got paging, and it's kind of a pretty typical search. These products exist in specific categories, and I want to go and get a distinct list of categories and the number of times that it occurs in each of those categories. So to do that, I'm using a package that I created called examine facets. And you can use this too. It's really simple to get up and running with facets with very, very little code. So we've got a typical examine query here. Let's not worry too much about it. What I can do is install the examine facets package, and then within my search, I can actually execute a simple query. So add to my query, query.and facet, and say, hey, I'd like you to facet based on this field. In this case, let's call it the categories field. Categories. And then when it comes to rendering it, is one I prepared earlier, we can go on our search results collection. This is just the typical examine search results collection dot get facets, and actually get the facets out the other side, including strongly typed ones. So it will go and fetch the content for those categories. I'm very quickly build that. I know I'm running out of time. And what we should hopefully see on the front end is it will pull back a distinct list of the categories that exist in the system. This is with literally one line of code that I've actually had to write, and no logic either. So it's going to do all of the fun for me in the background. We will just very quickly load that one up whilst in the background. I'll pull those up on the screen as I know I'm out of time. If you want to go and check out these packages, and there's a load of documentation on these with a bit more detail of how they're actually working, please do. Please give them a try. I think these are, in my eyes, the go-to solutions for when you want to do an advanced search in Umbraco. And let's see, hopefully, this will spin up in any second now with our distinct list of categories. Praying to the demo gods. This is working 2 seconds ago, so. There we go. Fantastic. So you can see there, we've got all of the categories. And I'm completely out of time, but thank you very much for listening. My name's Callum. I'm on Twitter. Please reach me for any questions, and enjoy the rest of Codegarden.